All right, let's talk about the single most important piece of software running on your computer right now, the operating system. We're going to peel back the layers and demystify this thing by thinking of it as the ultimate can't-live-without-it manager.
So, to really get what an OS does, let's just flip the script for a second. Let's start with the thought experiment. What would happen if it just wasn't there? Imagine your computer, but with no boss, no manager in charge of anything.
You'd have pure, unfiltered digital chaos. I mean, every single application you open would be in a total free-for-all, all fighting for the computer's brain, the CPU, its memory, even access to the printer. Your web browser, your music, your game, all demanding everything, all at the same time. And the result? Well, nothing would work.
And that is precisely why every computer has this ultimate manager, the operating system, or OS. It's the silent hero that steps into that chaos and brings order to the entire system.
So, what's the official definition? Our source material puts it this way. An operating system is the software that acts as an intermediary, a middleman, between you and the computer hardware. Its job is basically to make the computer easy for us to use while making sure all the hardware is being used as efficiently as possible.
Now, this manager really has two main hats it wears. First, it's a resource allocator. It's the one who decides which program gets to use the CPU, how much memory each one gets, and who gets to turn with the printer. Second, it's a control program. It's kind of like a referee, making sure all the other programs are playing by the rules and not causing any system-wide meltdowns.
And trust me, this manager's job is incredibly complex. In fact, what you're seeing here is an actual university exam paper for an operating systems course. Entire computer science degrees spend whole semesters just trying to understand this manager's playbook. Yeah, it's that important.
So, let's break down what this manager actually does. First up on the duty roster, managing all the different programs and tasks that are running. A good way to think about it is like a project manager juggling a whole team of employees, each working on their own individual projects.
But hold on. When we say the OS is managing programs, what is it actually managing? This brings us to a really key piece of jargon. So what exactly is a process?
A process is a program that's currently running. It's a program under execution. And this is a really critical distinction. That word processor file just sitting on your hard drive, that's a passive thing. But the moment you double-click it, boom, it becomes an active process that needs resources to run. And it's those active tasks that the OS manages.
And every single process goes through a life cycle, just like this. It starts out as new. Then it moves to the ready state, basically waiting in line for its turn on the CPU. Then it's running. Sometimes it might enter a waiting state if it needs something, like you to type on the keyboard or for a file to load. That's I/O, by the way, input-output. And finally, when it's all done, it's terminated. The OS is the tour guide for this entire journey.
So, how in the world does the manager keep all of this straight? For every single process, it keeps a detailed file, kind of a cheat sheet, called a process control block, or PCB. This file tracks everything: what state the process is in, its priority, its memory, everything the manager needs to know.
All of this leads to one of the manager's most vital skills, CPU scheduling. I mean, with dozens of processes all in that ready state, waving their hands for attention, the OS has to constantly decide which one gets to use the CPU right now. It's this high-stakes art of deciding who gets to work next, and it's the very reason your video doesn't freeze just because a file started downloading in the background.
Okay, so the manager is handling the workforce of processes. But where do they all work? Let's look at the manager's second major duty, managing the physical workspace of the computer, its memory, and its storage.
So how does this manager assign office space, computer memory, to each program, while making sure they don't step on each other's toes or start messing with each other's data?
The secret is this really clever separation between two kinds of addresses. Your program uses what's called a logical address. It's like an internal map of its own office. But the OS translates that into a physical address, which is the actual physical spot in the computer's RAM. This constant mapping is what keeps everything separate and safe. And one of the most brilliant techniques for doing this is called paging. The OS chops up the physical memory into these fixed-sized blocks called frames, and it does the same thing to the program's memory, calling those blocks pages. Then it can just slot those pages into any available frames wherever they might be. It means a program's memory doesn't even have to be in one big continuous block.
Now, this manager is in charge of more than just the main memory. It oversees this whole hierarchy of storage.
At the very top, you have the ridiculously fast and expensive stuff like CPU registers and cache. And as you go down, storage gets a lot cheaper and a lot bigger, but it also gets slower. The OS's job is to play this constant game, moving data around to keep the most used info on the fastest levels to give you the best performance.
And of course, for all the stuff you want to keep forever, the OS manages the master filing cabinet, the file system. That's the system that organizes all your documents, your apps, and all the system files into the folders and directories that you see every day.
So we know the manager schedules tasks and allocates space, but how does it actually enforce its decisions? I mean, how does it stop a buggy application from just taking over the whole system? What's this manager's secret weapon?
Well, the OS's authority isn't just based on trust. It's actually enforced by the hardware itself through a really fundamental feature called dual-mode operation.
Here's how it works. The computer basically has two modes it can be in. There's user mode, and that's for your applications. Think of it as an employee's access card with limited privileges. But then there's kernel mode, and that is the manager's master key. When the OS itself is running, it operates in kernel mode, giving it full, unrestricted access to absolutely everything. This means any instruction that could affect the whole system, like messing with memory allocation or halting the computer, is a privileged instruction, and these can only be executed in kernel mode. If a regular program in user mode tries to do one, the hardware itself steps in, stops it, and hands control right back to the manager, the OS. This is the absolute bedrock of system stability.
And this really brings everything full circle. The operating system truly is the invisible hero. It's the thing that takes a lifeless box of circuits and completely transforms it into the organized, functional digital world we use every single day.
From managing simple processes on a single computer to orchestrating these vast distributed systems in the cloud, the OS has always been evolving. And that leaves us with one last, really fascinating question to think about. As our technology continues to change, what will the ultimate manager of tomorrow even look like?